Hello.
Hello, Dr. Kim.
Hi, thank you. About the next week's schedule. Next week you will take quiz number 1 after midterm review. Quiz number 1 from chapter 1 to chapter 7, about 30 questions, true or false, and a couple of multiple choice. I will ask you turn on the camera, and then I don't know if you can use your camera, but if you can prepare the camera during taking a quiz, and then on Wednesday during you take midterm, let me see your face. Midterm next Wednesday, 4 questions from assignment 1 to 4. I will send you email individually, midterm questions. And then I made this reservation slot here in Moodle. So if you want to take midterm in class, please now reserve your seat to let me prepare your paper exam. Otherwise, you can take it online. Okay, any question about now quiz and midterm?
I have a question.
Mm-hmm.
For the midterm, if we take it online,
Yes, you can take it online.
do we write it down, like the answer in a notebook, and send you like a scanned copy of it, or how are we gonna do that?
The same as hand-in assignment. So it's like I will email you the question individually, and then when it starts, you can download or print out, and then answer. You can make it Word file. You can make it like a picture. Take a picture, whatever. The same method you hand in the assignment. Okay, any other question about quiz and midterm? So quiz and midterm, I'll say again, during the class time. So every you take it quiz and midterm simultaneously. Okay. Okay, if we don't have a question, then continue chapter 7. On Tuesday, we did a queuing model. Example 1 about the model 1. Just a review. Drive-through window, usually one channel, one waiting line. And then we can assume source of population is infinite. And service pattern is exponential. Then model 1, arrival rate is 15. And average service time is 3 minutes. We need arrival rate and service rate to solve such problems. So arrival rate is given 15 per hour And then service rate is not given directly, instead given time, 3 minutes. So arrival rate 15 is time unit is hour. So we need little calculation. Take 3 minutes. So in an hour, how many customer can be served? So 60 divided by 3 minutes equals 20. So service rate, arrival rate is not a time unit. It is how many customer arrive, how many customer can be served in certain time unit. And then average utilization, rho equals lambda over mu, arrival rate divided by service rate. So 15 divided by 20, that is 0.75. LQ, average number waiting in line. How many customers in waiting line? Model 1 used this formula to find out how many in Q. So 15 squared divided by 20 times 20 minus 15. So on average, 2.25 cars in waiting line. And then total number of customers in the system, LS, equals arrival rate divided by service rate minus arrival rate. So equals 15 divided by 20 minus 15. So on average, 3 customers or cars in the system. And average time waiting line, how long wait in waiting line to get service. LQ, how many customers in waiting line divided by arrival rate equals 2.25 divided by 15. So 0.15 hour. Convert this hour to minute times 60 equals 9 minutes. And average total time in the system, including waiting time and service time, LS, total number of customers in the system divided by arrival rate, equals 3 divided by 15, 0.2 hour times 60, so 12 minutes total time in waiting and service. Okay, practice problem. A quick loop operates a fast loop oil change garage. On a typical day, customers arrive at the rate of 3 per hour. So arrival rate, given arrival rate is three. And loop jobs are performed at an average rate of every 15 minutes. 15 minutes. So service rate mu equals 60 divided by 15 equals 4. Then assume poison arrivals and exponential service. And then one fast loop oil change in a garage. So one channel, so use model 1. The utilization of routine utilization rho equals lambda over mu. So 3 divided by 4 equals 0.75, so 75%. And the average number of car in line, LQ, equals lambda square divided by 2 mu. It is 2 mu, am I right? Let me check. No, it is now mu. But 2 mu is mu. Mu times mu minus lambda equals 3 square divided by mu is 4 times 4 minus 3 equals 9 divided by 4. So it will be 2.25. So on average, 2.25 cars in the waiting line. Okay, then the average time a car wait before it is now route. So before, so waiting time, so L W Q equals LQ divided by lambda. 2.25 divided by 3 equals the same 2.75 hour times 60 equals 45 minutes. So wait quite long. And the total time is now WS, that is LS divided by lambda. Then LS is I need formula. So LS is lambda over mu minus lambda and divided by lambda equals 3 divided by 4 minus 3 divided by 3. So that will be 3 divided by 3 equals 1. It is now about an hour. Equals 60 minutes. Okay, any question? This is not simple. Okay, then clear. Change. Okay, next thing. Example number 2, equipment selection. A robot washes a car the rate of 1 every 5 minutes. Customer arrival rate is 10 per hour through drive-through window. Robot washes. So we can assume the service time is constant. When service time is constant, the service pattern is constant, then we use model 2. Similar, but just the formula difference. And arrival rate given 10, and service rate every 5 minutes. So 60 divided by 5, that is 12. Average number waiting in line, how many customers in waiting line. Model 1 formula without these 2 on denominator, but the model 2 has 2 constant here. So using this formula for the model 2, then 10 squared divided by 2 times 12, 12 minus 10, that is 100 divided by 48, 2.08333 customer in waiting line. And then LS, LQ plus lambda over mu utilization rate. So 2.08 LQ plus 10 over 12 equals 1.73 cars or customers in the system. And waiting time, LQ divided by lambda or this formula. So 2.08333 divided by 10, that is 0.208333. And then average total time, WQ plus 1 divided by mu, that is LS divided by lambda. So LS, it was 1.7361, so divided by 10 is 0.10. This one is not a little bit wrong. Right. 1.7. This one is wrong. It's supposed to be bigger than this one. LS, maybe this one is maybe calculation miss, just okay. So, but later I will fix it. Okay, this is model 2. And then model 3, if there are multiple waiting lines or channels, then we use model 3, multi-channel. 3 clocks now work. So 3 waiting line or 3 channels. Customer arrival rate is 40 per hour, and then service rate is 20 per hour. Cost of service clock too higher if this system need more worker, then to hire one more clerk or worker, pay $6 per hour. And cost of a customer waiting line is $12. Customer's time is variable. So customer wait in line, and then we can value a customer's cost. So this example, $12 customer cost per hour, and then open 8 hours and 3 clerks work. So if only one channel, then we can use model 1 or model 2, depending on the service pattern is random or service pattern is constant. But if multiple workers work, then we cannot use formula to get LQ. Instead, we use chart. To use the chart, we need utilization rate. So lambda over mu. Customer arrival rate is now 40 lambda, and service rate is 20. So 40 divided by 20 equals 2. And then we need how many channel. So using a chart with this utilization rate and then the number of servers, S equals 3 for this example. Then from the chart, the first column is utilization rate, so 2. Then second column is how many, the number of servers. So 2 utilization rate, and then 3 servers, the number of servers. So LQ is 0.889. LQ is how many customers in waiting line on average. So using this LQ, we can calculate cost of a customer in waiting line. From the given information, customer waiting line, the cost, the value is $12. So on average, 0.889 customers in waiting line, $12 per hour cost, and then the store open 8 hours. So with this, utilization rate is 2, and then the number of 3, then customer cost is 85.34. Then consider if hire one more clerk or one more worker, then the number of server is 4. It was 3, but hire one more, then 4. And the utilization not changed, the same. Then utilization rate 2, and then the number of server is 4. Then LQ is 0.174. So with this, hiring one more clerk, then customer cost change like this. On average, when 4 workers work, 4 channels, then on average, 0.174 customers in waiting line, $12 cost per hour, and 8 hour open, and customer cost is 16.7. So by hiring one more clerk, how much customer cost is saved? This one, when 3 workers work, customer cost we calculate earlier. And then customer cost when 4 workers work. So by hiring one more clerk, 68.64 saved. But to hire one more clerk, pay $6 per hour, and then during the store open, the 8-hour open, so pay $48. So save this much, but pay this much. So this cost saved, and then cost. So save this much minus cost this much equals 20.64. So from this process, the result, the cost reduction by adding another clerk, if this result is positive, then decision is hire one more clerk or one more work. If this result is negative, then the decision is don't hire, because there is no save cost. Say again, if this one, the result is positive, then decision is hire one more clerk. If this result is negative, then decision is don't hire, because there is no cost reduction or save cost. Questions so far? Okay, practice problem. Okay, machinists who work at a tool and die plant must check out parts from a part center. An average of 8 machinists per hour. So arrival rate is 8. And the part center is stepped by 1 clerk who take an average of 6 minutes. So mu equals 60 divided by 6 equals 10. Assume Poisson arrival and exponential service time situation. Now 1 clock work, and then assume Poisson arrival exponential service pattern time. So if it is only 1, then we can use model 1. But hire 1 more clock, then use model 3. And this one open 8 hours, and then $12 customer cost, and then another $12 to hire 1 more worker. So first we need LQ. Even is model 1 we can use still, well, we can use that just a moment, I will bring up the chart. Now we need LQ and then the number of, but here, if utilization rate is low, then still we can get LQ, one channel like this. So we need LQ first. Oh, it's gone. Do it again. Lambda equals 8. And then mu equals 60 divided by 6 equals 10. So utilization is 8 divided by 10 equals 0.8. And then number of server equals 1 now. We may use the formula to get LQ. Still LQ equals lambda square mu times mu minus lambda. You can use this formula because it is one channel now. But if we can use the chart, still we can use chart like this. So utilization rate is 0.8. And the number of server is now 1. So 3.2. So LQ, when S equals 1, then 3.2. And then if higher one more, then LQ, S equal 2, then this one, 0.152. And then move this one away. Okay, so customer cost when S equals 1, then equals customer cost equals LQ 3.2 times customer cost is $12 times then 8 hour. So I need just a moment calculation. So it is not that one. This problem. Calculation. Sorry, it take time. It is 300 or 7.2. And then if higher one more S2, then customer cost equals LQ is 0.152 times $12 times 8 hours, that is $14.59. So by hiring one more, cost to save, $307.2 minus 14.59 equals $292.61. And then cost to hire one more, that is 8 hours times $12, that is $72. So by hiring one more clerk, save this much, but cost is this. So cost reduction equals 292.61 minus 72, that is $220.61. So this is the result. Cost reduction result is positive. So decision is like this. Because this result is positive, so by hiring another clerk, the center can save cost. So the answer is yes, hire one more clerk. Do you have a question?
And the cost of the additional service clerk, where'd you get the $9?
$9? This one is it should be 12 here, 12. I'm sorry. Okay, just a moment. I said wrong. This one is $9 here. $12 is just customer cost. $9 is to hire. So this one $9 is right. I used the wrong number, but calculation is right. I made a mistake here.
Now.
Okay. So it's supposed to be $9, not 12. Thank you for a correction. Okay, any other question? Okay, now I will bring up previous now because you have assignment 5 from this chapter, and due is not this Sunday, next Sunday, because you will take quiz and midterm next week. So this assignment due is Sunday, October 18th. And then I will bring up the previous assignment to go over. So I will give you a couple of minutes, read And then think about it, how you solve this problem. Then I will go over. Okay. Student arrive at a registration office at the rate of an average rate of 18 per hour. So arrival rate lambda equals 18, and student request take on average 6 minutes. So mu equals 60 divided by 6 equals 10. So to solve this waiting line model 3 question, you should figure out arrival rate and then service rate carefully. Then you need raw utilization rate, that is 18 divided by 10 equals 1.8. And then now 2 workers work, so S equals 2. And then if hire one more worker, then S equals 3. From the chart, when is 0.8, raw the utilization rate is 1.8, and 2 workers, and LQ, 2 workers, 7.6, 7.4, and then LQ3, 0.532. Then we need the customer cost when 2 workers work. So customer cost when S equals 2, that will be LQ times customer cost. It says $10 customer cost. So $10 times 8 hour open. That will be 613.92. And then customer cost when S equals 3, that is LQ is 0.532 times 10 customer cost per hour and times 8 hours open. That will be 42.5 0.56. So value of customer customer's time saved that is this one minus this one, 613.92 minus 42.56 equals 571.34 dollars. Hiring cost $12. Hiring cost $12 times 8 hours, that is $96. So by hiring one more clerk, cost reduction equals save $571.34, but pay $96. So that is $475.34 positive. So by hiring one more worker, save this much. So answer is yes, hire and more work. This is decision. If this is negative, result is negative, then answer will be no, don't hire. Because it's negative, then no cost reduction. Okay, question? Okay. Say again about the assignment. You have assignment 5. This one is similar to that previous assignment. I just reviewed. And due is not this Sunday, next Sunday. And then next Monday, I will review midterm questions. And then after that review, you will take quiz number 1 from chapter 1 to chapter 7, about 30 questions, true or false, and a couple of the multiple choice questions. So prepare lecture note or whatever you can use, because it is open note, open book. And the quiz is online. Okay, that's all. If you don't have a question, then see you next Monday.
Professor Kim, I have a question really quick.
Okay.
Is the midterm also going to be open note?
Yes.
Okay. And if we don't reserve a seat for the in-class midterm, do we have to record ourselves taking it? and send that to you?
Say again.
If we're not in class for the
Mhm.
midterm, do we have to record ourselves taking it and send it to you?
It's like an assignment. So, but not like an assignment. Assignment is like give you many days. So whenever you do, and then make it like a Word file or taking picture, and then upload on the Moodle, right? So it's the same. So after you finish, make a file and then upload on Moodle.
Okay, thank you.
Mm-hmm. Okay, any other question? Okay, good. And see you next Monday.
Thank you. Have a good weekend.
Okay, thank you, you too. Cameron, are you saying something? I cannot hear something noise. Yeah, email me, okay? Okay, thank you.